Dear Sim, Sir and Madam, I would like to present the work Optimization of Schematic and Technical Tools for Determination of Spatial Acoustic Signal Source Location on the polygon given in the Hamming space. The presenter is Bogdan Stambridge. Okay, so in general case, the task of determination of the source of the acoustic signal consists is in searching the location of the source of acoustic signals in the Cartesian or polar system. It's the example of this is shown on the figure 1. As you can see, this little squares is the matrix of the Hamming space in the two dimensional elements, make it possible to determine the source of the acoustics signal. In order to simplify some calculations, we first of all we could select some appropriate distance between two microphones. For example, we can just when we know the speed of sound in the air, we could align the distance between two microphones, for example, L0 to some calculated distance. For example, in case when we have the speed of sound of 330 meters per second, we can select the distance between the microphones, for example, to 33 meters, and it should reduce the complexity of the calculation in our device. So the process of the calculation, the source of acoustic signal, it could be done by using a special multi-channel digital device that could use digital correlation methods to calculate the source of the acoustic signal depending on the time differences in receiving the sound signal on, for example, 3 microphones in our case. So on figure 4, you can see the example where we we have some delays in the same timeline, and for example, you can see that in some point of time we receive the signal on one microphone, and on the other time slot we receive the same signal on the other microphone, and our digital correlator could determine the time differences between all three microphones. It's for example, in our case, it could be delta tab between this and this microphone, this and this and this and this microphone. Okay, so on figure 5, you can see the general schematic of the proposed digital correlator device to determine the source of the acoustic signal. Sorry. The blocks from 1 to 7, it operates with analog part of the signal, and blocks from 7A to 13 actually are the digital correlator itself, and the blocks which calculates the coordinate of the source of our acoustic signal. As a result, we propose the schematic of the modular differential adder, which consists of two main parts. It's logical XOR element and half binary adder, 1-bit adder, and hardware. So we can actually calculate the hardware and time complexity of our schematic. So as a result, we calculated them, and we received the next data. So, and as a result, we were achieved the next results. So we could reduce the time complexity and hardware complexity by 3 and 2 times accordingly. And here you can see the results, how many clock cycles we need to calculate the source of the acoustic signal when the correlator was started. It means when the process of the correlation was started. And so let me introduce some conclusions of that. We were able to reduce the hardware and complexity of our already proposed device by at least two times, and also we could increase the speed of our correlator by 5 times. That give us an opportunity to calculate the location of the source of the signal as quickly as possible. Thank you for your attention, and goodbye.